Hey, what's up guys? Scott here from Mobile Install Guide, and in this video I'll be teaching you how to use a digital multimeter to test for DC current. Now, when you're installing mobile electronics, it's not very often that you need to measure current, but if you find yourself with a car battery that drains if you don't drive the vehicle for a few days or even overnight, then knowing how to measure current could save you a lot of time and money. So make sure you stick around to the end of the video where I'll show you how to test for parasitic current drain, and I'll give you a few troubleshooting tips on how to identify where it's coming from. But first, let's head over to the whiteboard and talk about how you connect your meter to a circuit so it can measure current. So in the last video, we talked about how when you're measuring voltage, your meter needs to be connected in parallel with the circuit. But if you want to measure current, the meter needs to be connected in series so that it's actually physically a part of the circuit. If you find yourself needing to measure current often, or you just don't want to bother with disconnecting the circuit to connect the meter, you can use a clamp style meter instead. With a clamp style meter, you just put the clamp around the wire that you're testing and the meter will measure the current. But for this video, we'll just focus on meters that measure current through its test leads. So I've drawn a simple circuit on the board here with a battery and a light. Now if I want to measure how much current the light draws, I'll need to connect the meter in series with it. So I'll start by disconnecting the negative terminal of the battery, like that. And now the black test lead of the meter will go to the negative terminal of the battery, and the red test lead will go to the load side of the circuit. So now the meter completes the circuit, and the current will flow through the meter so that it can measure how much current the light is drawing. One thing to note, if you connect these test leads up backwards, don't panic, it's not going to do any damage to your meter. You're just going to get a negative sign in front of the current readout on the digital multimeter display. So now let's take a look at the meter and go over how to set it up. So here we have the auto ranging meter, and it has 3 different settings for measuring current depending on how much current you're measuring. It has microamps, milliamps, and amps. And you can see the symbols underneath each one. It has a straight line and a wave. That means that each one is capable of measuring either DC current or AC current. When you're determining which setting to use on the meter, it's important to start with the highest range first and work your way down. If I set this meter to the amp range and it was reading less than 1 amp, then I could go ahead and step it down to the milliamp range. If I was on the milliamp range and it read less than 1 milliamp, then I could go down to the microamp range to get a more precise reading. Make sure you pay attention to which test lead port corresponds to which setting. The black test lead will always go in this common port, but the red test lead will go in this port for the microamp and milliamp range, and it'll go in this port for the whole amp range. Also note that this meter can only measure up to a maximum of 10 amps, marked here and here, and it's fused, so if you exceed that, the fuse will blow to protect the meter. Now that you have a good understanding of how to set your meter up, let's hook it up to the battery and light bulb circuit on the test bench to see what it looks like in action. Alright, so I've got the 9-volt battery here with the positive terminal connected to one end of the light bulb, and if I touch the other end of the light to the negative terminal of the battery, that'll complete the circuit and the light will light up. Now if I want to test how much current this light bulb draws, I need to connect my meter in series with it. I've got the negative test lead connected to the negative terminal of the battery, and now if I touch the red test lead to the other side of the light, that'll complete the circuit again, and this time the current is running through the meter, so I can see that this light draws about 1 amp. So now that we've got the basics down, let's take a look at a common troubleshooting scenario, and I'll give you some tips on how to solve your battery draining problem. There are a lot of uses for measuring current with a digital multimeter, but in the mobile electronics installation world, it's not really something that comes up all the time. But there is one situation that might come up from time to time where knowing how to measure current with your meter could save you a lot of time and money, and that's a car battery that drains overnight. If you run into this problem on an otherwise healthy battery, the cause is usually a parasitic drain on your vehicle's electrical system. This happens when a circuit in your vehicle that normally is off when your vehicle is off actually stays on or draws current in some way due to a fault. This can be caused by aftermarket electronics. Maybe you've recently installed an alarm system or a remote start and accidentally wired a relay coil to constant 12 volts and ground. Or maybe you installed an amplifier and your remote turn-on wire is shorted to the battery cable so that the amplifier stays on all the time. It can also be related to a factory circuit. Maybe the dome light is staying on, or there's a faulty electronics component somewhere in the vehicle. Whatever the reason for your parasitic drain, your goal is to identify the circuit that is coming from so you can eliminate the problem. So let's jump under the hood and go over some troubleshooting tips. Okay, we're under the hood now, and the first thing we want to do before we start troubleshooting is to make sure that the battery is fully charged. So if I do a quick voltage check, you can see the battery sitting at 12.57, which is pretty close to the 12.6 that we're looking for. So now I'm going to change up the meter, set it up to measure current, and we'll get into getting a baseline measurement of how much current is being drawn from the battery. Alright, so I've got the meter all set up to measure current. I've got it set on the highest current range, the 10 amp range. I've already disconnected the negative battery cable. I've got the red test probe going to the negative battery cable. So now to get a current measurement, all I need to do is take the black test lead, touch it to the negative terminal of the battery. And you can see we got a reading here once it settles out. Looks like we're reading about 0.69 amps or 692 milliamps. Now all vehicles will have a small amount of current draw for the clock, the radio memory, and things like that, but it should be no more than 50 milliamps or 0.05 amps. So if you're seeing a reading like this, then it's time to start figuring out what's causing it. You'll want to do this by a process of elimination, and a good place to start is with any aftermarket electronics that you have in the vehicle. But before you start opening doors to get at the electronics, make sure you disable the door pin so that the dome light doesn't turn on and throw off your readings. You can clamp something around here to keep it shut, but this one's easy enough to remove. I'm just going to remove the screw, pull it out, disconnect the plug, and we're good to go. Now that you've done that, start eliminating your aftermarket electronics one by either pulling the fuse or disconnecting the power lead. Take a look at your meter in between each one to see if you get a significant current drop. If you do, then you found the culprit. If not, and you've already eliminated all of your aftermarket electronics, then it's time to move on to the vehicle's fuse box. Start pulling fuses one by one to see if you get a significant current drop. If you don't, replace the fuse and move on to the next. So for this example, I actually just left the dome light switch in the on position, so the dome light was on the whole time. Now if I remove the fuse for the dome light circuit, we can watch the current drop significantly. And now we're under that 50 milliamp range that we were shooting for, and we know that the dome light circuit was the cause of the parasitic current draw. Well, that concludes this tutorial on using a digital multimeter to measure DC current. I hope you learned something from the troubleshooting example, and if you have any questions on troubleshooting your vehicle, leave me a comment below and I'll be happy to answer. I want to thank you all for watching, and if you found this video useful, give it a thumbs up, share it with your friends, and if you haven't already, consider subscribing to the channel to catch all of my videos. If you're looking for some more in-depth explanations on how to use a digital multimeter, check out my other videos or head over to mobileinstallguide.com and check out the blog post. Links are in the description.